Okay, today we're going to start a new unit on scale drawing and scale models. Your eventual project is over here on the board. You're going to be making a scale model of your bedroom. And that's going to be your IB project at the end. But before we start on our IB unit, we have to learn some things about scale factor and scale models and scale drawing. So in your journals, we're going to take a few notes. The date today is 3/4, and the topic today is scale factor. Scale factor. So we use scale drawings all the time. So one of the things we use scale factor for is to make scale drawings. Some famous ways that we use scale drawings that you know already are blueprints. If we have construction, we're trying to build a house or a building, or maps. How many of you have GPS in your car or on your phone that you use? Yeah. And all those satellite maps that come up, those are a scale model of what the roads are really doing. The next thing that we use a lot is a scale model. If you're going to try to sell a big commercial building of real estate, you're probably going to try to build that building in a small model so people can imagine how it's going to look. One of the most famous models that we have is a globe. When we study geography, we don't study the Earth by actually running to Bangladesh. We look at a globe, which is a smaller model of what the Earth looks like. Both scale drawings and scale models are built on the idea of proportional relationships. Proportional relationships. And we've just spent the whole unit on proportions, right? And solving proportional relationships. Some vocabulary you need to know is there will be an original and then an image. If you're building a house, your original is the blueprints that you're building from, and the image is the house that you build. If you're studying the Earth, the original is the Earth, and the image is the globe. So one is a proportional representation of the other. Scale factor is today's topic. Scale factor is our learning goal. If we can understand scale factor today, we'll be ready to move to the next lesson. Scale factor is the number, usually expressed as a ratio, that you multiply by to get from the original to the image. So scale factor is the number, usually expressed as a ratio, that you multiply by to get from the original to the image. As soon as you have this in your notes, would you put your pencil in the air, and we're going to try some problems together using these ideas. Okay, and if you look at your textbook on page 576, we're starting with a map that shows the distance between Hagerstown and Annapolis. And those are both found in the state of Maryland. So the first instruction says, use a centimeter ruler to find the distance between the maps. So I'm going to look for a centimeter ruler. Let's see if I have one up here. And I'm going to measure from here, from Hagerstown, all the way to Annapolis. And I find that the distance is, on the map, going to be 4 centimeters from Hagerstown to Annapolis. So my example says that the scale is, up here in the key, 1 centimeter to every 24 miles. So that's our first ratio. 1 centimeter to 24 miles. And that information, that scale factor, was located right in the key. Put your finger on the key where I got that from and show your neighbor. And then when we measured on the actual map, we found the distance was 4 centimeters. My question is I'd like to know how many actual miles is it then from Hagerstown to Annapolis. So you have something that looks really familiar to you. Who wants to tell me what this is called? What do we call this kind of a problem? We did a bunch of them. They take 5 steps. Molly?
Cross product?
We're going to use cross products to solve it. This is called, Andrew? A proportion, right? Is this a proportion? Okay, so the first thing I want you to do is put your ovals around the numerator and the denominator. So we have 1 centimeter times X miles, and in our proportion work we don't have to have labels, but they do have to be on the original step. The next step is to make our ovals denominator times numerator, so we have 24 times 4. 1 times X is X. 24 times 4 is going to be 96. So we find out that the actual distance is 96, but we need a label. We look back in our original proportion. What was our label for X?
Miles.
Miles. Good. Now let's think about this, because we also have to have a sentence now describing the relationship. Remember, original and image. So what we started with was a key. For every 1 centimeter on the map is 24 miles in real life. So what we found was 96 miles. Here's what our sentence would look like. 4 centimeters on the map is equal to 96 miles in real world measurement. Okay, we're going to try another example, example 2. So the cell phone artist created this for an ad. They drew this. And she said that the scale is 5 inches to 1 inch. Go ahead and show your neighbor where I found that. 5 inch to 1 inch. So whenever they give you the scale, that's your first fraction. Just like the key on the map was our first fraction or ratio. In this case, our first fraction is 5/1. And we want to know, okay, in the advertisement, how big will this ad actually be? In real life, that phone is 4 inches. So when we do our proportion, we find out that we get 20 inches. So the length of the cell phone on the advertisement is actually 20 inches long. So that's like a newspaper ad, right? It's about this big. It's a big picture of a phone. So we're going to try B. A scooter is 3.5 feet long. Find the length of the scale model. We built a model of the scooter if the scale is 1 inch equals 3/4 feet. I want you to write down just the proportion you think you need to solve that, and then make eye contact with me. Write down just the proportion. Remember, the first fraction is always the scale. Marlon, what's the scale in this case? Anyone at your table can help you find it. Or an example 2, B.
Which one?
I'll come out.
Okay, so this is example 2, correct? And here's B. So now you tell me, read this and tell me what the scale is. I'll come right back to you. Okay?
Meanwhile, whisper to your neighbor when you found it while we wait, and Marlon's going to tell us what it is. So Marlon, what's the scale?
1 inch,
2.
3/4 feet.
Good. So that's our very first fraction. 1 inch to 3/4 feet. Always start with the scale. Then we know one other number. Who can tell me what the other number we know is? What's the one other number? Brian?
3 1/2 feet long.
3 1/2 feet. So if we have inches on the top and feet on the bottom, where do you think the feet is going to go?
On the bottom.
No, on the bottom, good. We want it to line right up. So we have 3 1/2 feet. So what we want to know is X inches. Now that you have that, go ahead and solve. Stand up when you're done. Thank you, have a seat. Okay, how many of you were able to get this step, and then we thought, I wonder what I do here? Do you remember that when you have a coefficient and a variable squished together, in between, what operation is happening? What operation is happening there? Yes? Times, multiplication, good. So we have to use the opposite of multiplication to undo that, to take it apart. So we're going to divide by the coefficient with the variable. So let's rewrite 3 1/2 divided by 3/4 equals 3/4 x divided by 3/4. Well, we know anything divided by itself is just 1. 1 times x is x. So now we're left with this side. And we know that to divide fractions, we have to use keep, change, flip. And we have to change this into an improper fraction first. So 2 times 3 is 6, plus 1 is 7. So we have 7/2 divided by 3/4, which would be times the multiplicative inverse of 4/3. So now taking it from there, stand when you have the solution. Okay, and have a seat. Thank you. 24/6 is an improper fraction. Who changed it into a mixed number? Kevin, what'd you get?
Oh, I got 4, and I simplified it.
4 and?
Uh,
Okay, try again. What'd you get?
4 2/3.
4 2/3. So 6 goes into 24, how many times? 4. And what's left is 4 6. And 4 4/6 would simplify to 4 2/3. So all of those things you know how to do. We worked with complex fractions. You know how to simplify fractions. You know how to turn mixed numbers into improper fractions and improper fractions into mixed numbers. And all of that is necessary to get that problem done. Okay, looking now, please, at example 3. Example 3 says, find the scale factor of a model sailboat if the scale is 1 inch to 6 feet. Okay, so Kevin, if that's my scale, what's my very first fraction going to say?
1/72.
Remember, your scale is always first.
1 inch over 6 feet.
1 inch over 6 feet. Good. All right. And the sailboat is 72 inches, the model, over 1 inch. So the scale factor is going to be 1/72. So now we're going to use that same example to do C. All I want you to do is write down what the proportion would be. What is the scale factor of a model car if the scale is 1 inch equals 2 feet? 1 inch equals 2 feet. Now, in order to find the scale factor, they have to have the same measurements. And it's always easier to change your large measurements into small measurements. So, which is smaller, inches or feet?
Inches.
Inches. So 1 inch would be equal to how many inches if we have 2 feet?
24.
Exactly.
24.
24. So our scale factor is 1 inch to 24 inches. What they're showing you is that for scale factor to be correct, you have to have the same increments. All inches, all feet, all yards. Turn the page one more time. The very last example we're going to talk about today is 4, which is a blueprint of a house. Go ahead and look it over for a minute. They've given us the length of bedroom 1 and the width of bedroom 1. They used proportions to find both. They found out that the width of the bedroom is is 6, and the length of the bedroom is 24. Who remembers the formula for area of a rectangle? Area of a rectangle. Area equals. Yes.
Area equals width times length.
Yes, and usually we say length times width, but that's exactly right. All right, so if we look up here, area equals length times width, so it would be 24 times 6. And this is all for bedroom 1. So put your finger where it says bedroom 3. Bedroom 3. So bedroom 3 has a length of 3 inches. And what's its width?
1.
Okay, so bedroom 3 has 3 inches over 1 inch, and this is its length. And what's our scale factor? Every half inch represents 3 feet. So every 0.5 inch represents 3 feet. Now, 3 feet is how many inches? Tell your neighbor and then tell me. You can use your calculators if you're not sure. What'd you get, Logan? 36. Okay, so on the drawing, it's 3 inches over 1 inches. The scale is a half inch to 36 inches. Solve now for the length. Stand up when you have the length. And to talk to the camera for a minute, once you find the length, then you'll find the width, and then you'll do length times width will give you the area. So Shelby, I think that's all the time we have on the tape. Can we stop that now?